Good afternoon, class. Today we're going to be looking at assignment 18, operations, difference quotient, and composition. Let's see. Operations, difference quotient, and composition. Oh, let me end these slides. Okay. Operations, I mean operations on functions. Now, the four operations of real numbers, addition, subtraction, multiplication, and division, can be applied to functions. And addition, subtraction, multiplication, and division are of functions. It's just plain old algebraic addition, subtraction, multiplication, and division. So you'll see there's not really anything new here in terms of addition, subtraction, multiplication, and division. Oh yeah, let me write the date up here so I know which day these notes go for. There. To discuss addition, subtraction, multiplication, and division, I think we should look at an example. As I said, there's not really any new algebra here for this first problem. They give us two functions, and they want us to find f plus g in terms of x, f minus g, f times g, and f divided by g. Now give me a moment to write these problems down. Okay. F of x is equal to 5x plus 2, and g of x is equal to 4x minus 3. They want us to find f plus g, f minus g, f times g, and f divided by g, and they want us to give the domain of each of them. Well, when we look at, let me switch over. Just for the record, they don't ask us to give the domain of these first two functions, the f and g functions. But when I look there, y equals mx plus b, y equals mx minus b, those are linear functions. If they'd asked for the domains of f and g, what would they be? I don't see any fractions. I don't see any square roots. So unless we're told otherwise, what would we assume the domain is for these two functions? Okay, negative infinity to positive infinity, all real numbers. That'll become important in a moment, but we'll start off with just f plus g. You're adding f and g. So we know f is 5x plus 2. And you'll notice I'm enclosing that f, 5x plus 2, in parentheses just to make a note. Those terms came from f of x. Plus, now we want g of x. Well, g of x we know is 4x minus 3. They gave us that, so we'll enclose it in parentheses. And addition of functions is just plain old algebraic addition. You know how to add these expressions. You're going to have to combine like terms. I see parentheses here. I see parentheses, but I think they're unnecessary sets of parentheses. I just stuck them there for pretty, just so that it was clear the 5x plus 2 together came from the 5x plus 2 f of x function. So I can just drop those parentheses. That's an unnecessary set. It's as if we're multiplying through by 1. So we have a 5x plus 2. What about this second set of parentheses? I got what? I don't see a coefficient there, so I assume it's just a plus 1. What am I going to do? Am I going to have to change anything here? I guess a better question is, in a moment we're going to do f minus g. When there's a minus there in place of a plus, are we going to have to change anything? If you have a minus sitting in front of a set of parentheses, it just stays the same. I mean, you have to go through changing the signs, but when there's a plus multiplying by positive 1, that doesn't change anything. It's another unnecessary set. And then we can just combine like terms. As I said, addition of functions is plain old algebraic addition. So 5x plus 4x, that's 9x. Then we have a 2 minus 3. What's my constant term going to be? 9x. 2 minus 3 is minus 1, isn't it? 2 minus 3 is a negative 1. So our first answer is 9x minus 1. Oh. Now f minus g. That says take f of x, which is 5x plus 2, minus, do we have anyone over there in the peanut gallery? Is there anyone over there? No? Ah, good, then I don't need this. Ah, there. Ah, I forgot to turn it off there. I can take this coat off. Oh, we're past the stage of being formal, aren't we? This is what, the end of the 8th week. This is mid-semester. So, oh, I better start saying what I'm doing. The minus, we have f of x minus g of x, they gave us as 4x minus 3. The first set of parentheses, once again, it's an unnecessary set. There's nothing to distribute in front of it other than maybe a positive 1, which doesn't change anything. What about this second set of parentheses? It has that green minus sitting there. Okay, so instead of that positive 4x there, we're going to have a minus 4x. And in place of that minus 3, we're going to have a positive 3. And it's still a matter of combining like terms. Function addition and subtraction is just plain old algebraic addition and subtraction. We know what to do here. 5x minus 4x gives me 1x. 2 plus 3 gives me a constant term of. Okay, so there's f minus g. Oh, I'm going to write these all out, then I'll type them in. Okay, so I don't have to roll around so much. And now f times g. Notice there's no symbol there, so if there's no operation connecting the things, we assume that it's multiplication. And that says take f of x. We know what f of x is. It's 5x plus 2. And we're going to multiply by g of x. G of x is 4x minus 3. And it's a binomial times a binomial. Function multiplication is plain old algebraic multiplication. How would we multiply this? What would we use? Binomial times a binomial. FOIL? I agree, so let's get started. We'll FOIL the stuff out. First, 5x times 4x. I'll get us started since y'all are shy today. 20x squared. Outer. Okay, so minus 15x. Inner. Okay. And last, positive 2 times negative 3 gives me a. So we have 20x squared, negative 15x plus 8x. That's a minus 7x. And what else do we still have stuck on there? The minus 6, I agree. And there's one other operation, f divided by g. Generally, division is more involved than addition, subtraction, multiplication, and multiplication, but not here. We're representing the division with a fraction bar. We have f of x on top. That's a 5x plus 2. And on the bottom we have a 4x minus 3. If we had exponents, we would try to factor and cancel these common factors, but can either of those things be factored? 5x plus 2 or 4x minus 3? Nothing you can do to factor and cancel? Here's your final answer. Any questions there? They want the domain for f plus g, f minus g, f times g, and f divided by g. Remember, we already said for f and g, no fractions, no radicals, so the domain's all real numbers in the original functions. F plus, f minus, and f times are all going to have the same domains. Look throughout the work. Don't just look at the final answer. Look through and ask yourself throughout the work, are there any fractions? Are there any square roots? I don't see any fractions or square roots. Linear functions, the domain and range are both all real numbers. So for f plus g, f minus g, and f times g, the domain is negative infinity to infinity. Any questions on my logic there? As we look through that work, we don't see any fractions, so there's not going to be any denominators of 0. We don't see any square roots, so there's not going to be any imaginary numbers. F and g are linear functions, hence the domain, all real numbers. But I'll tell you right now, the domain for f divided by g will not be all real numbers. I look there and I see a fraction. So, remember we said, when looking at domains, you have to avoid a number divided by 0 and the square root of a negative number. Well, we don't have any square roots and negatives, but I think we have a fraction. That's the way we would find those denominator cut points with the cut point method. 4x minus 3. We don't want it to equal 0. So that means 4x can't equal 3. So x cannot equal 3/4. And let me do something. It still seems too bright in here, doesn't it? At least when I'm sitting up here looking over there, it seems bright. Okay, so for this fractional function, we could write out the domain is all real numbers except for 3/4. But you know that's not how they're going to want you to write it. You know that's not how they're going to want you to write it on My Math Lab. How are we going to have to write that? Well, how are we going to have to enter that on My Math Lab? There's a number line. There's 3/4. We don't want to shade in that. We're discarding 3/4. But it could be any number to the left. Any number to the right. So, how would we say that? Call out this left-hand interval the way you would if you were typing it in. What would you type first? A parentheses, negative infinity, comma, 3/4, and you don't want to include 3/4. It has an open circle, so there's another parentheses. Union, now we want the second interval, the one to the right of 3/4. Call it out as if it were you were typing it in. Parentheses, 3/4, comma, infinity. In parentheses, for what it's worth, problem 1 is the longest problem in the assignment, and the funny thing is it really doesn't have, there's no new algebra here. We'd already found domains. We'd already found domains of rational functions. We knew how to add, subtract, and multiply algebraic expressions, so there's really no new algebra there. But I think we're going to have to go, any questions there? F plus, F minus, F times, F divided by. The domain for F plus G, F minus G, and F times G is all real numbers. For the rational function, the quotient, you can't let the denominator be 0. Write it using interval notation. That's the longest problem in the assignment. Okay, so we had what, a 9x minus 1. F minus G, that is an x plus 5. F times G, that's a 20x squared. Get out of the exponent position. Minus 7x minus 6. And F divided by G. What do you think I'll do first? Oh, I don't think I need a parenthesis around the F divided by G. I think I'll use that quotient, that fraction hot button there. And then I have a 5x plus 2 on top and 4x minus 3 on bottom. And then they're going to make, then we have to type in the domain for F plus, F minus, F times, and F divided by. So here goes. Left parenthesis, negative infinity, comma, infinity, right parenthesis. And since I'm going to have to type that 3 times, I'm going to copy and paste it. Here's F plus G. Click here. F minus G's domain. F times G. And, oh wait, that's not all real numbers. That's that messy one, remember? That's the negative infinity to 3/4 union 3/4 to infinity. So here we go. Negative infinity, comma, 3/4, close parenthesis, union, open parenthesis, 3/4. Get out of the denominator before you type your comma, infinity, right parenthesis. Any questions there? Okay. So, operations, the four basic operations: addition, subtraction, multiplication, and division. The operations that can be applied to real numbers can be extended to functions, and it's just algebraic version of those operations. Number 2 and 3 deal with something called the difference quotient. Okay, the difference quotient is a fraction using functional notation that's important in a calculus class. For our purposes, it's just practice using function notation. The difference quotient is defined to be f of x plus h minus f of x all divided by h. To simplify a difference quotient, what I'll do is break the problem into 3 parts. I'll first of all find f of x plus h, and then I'm going to take away the original function's terms. That's the minus f of x part. The last thing I'll do is divide by h. So, let's look at that problem number 2. Problem 2, they're breaking it up into the 3 parts that I use. I use this definition in my business calculus classes, and I split it up the same way they do it here on number 2. First of all, find f of x plus h, then subtract off f of x, and the last step I do, I divide by h. Now, number 3, they're just giving us telling us find the difference quotient. They're not asking us to, they're not saying break it into 3 parts. I will still break it into those 3 parts, as you'll see. Part A, we want to find f of x plus h, and I'll tell you right now, this part A is the longest part of difference quotient problems. You'll see what I mean in a moment. Okay, so, I better write down what the function was. I got all carried away. I got to know what the function is. This is number 2. The function we're working with is f of x equals x squared plus 9. Let me write that down. Okay. So part A, we're trying to find f of x plus 9. I mean x plus h, not x plus 9. They want us to find f of x plus h. We know how function notation works. This says go to my function f, and wherever I see a variable, replace it with the stuff in those parentheses. So I'm going to replace that blue x with the red x plus h. So I'll have an x plus h. I still have that square. What else do I have stuck on here? I replaced that x with x plus h. I have the square. What? The plus 9. I agree. I think my blue pen is going. We know the order of operations. We need to deal with that exponentiation right there. x plus h quantity squared. Here's where most people make the mistake. They square the x and they square the h. You can't do that. Think back to when we were working with complex numbers, the second class meeting. We had something like 3 plus 5i quantity squared. If it's a sum or difference being squared, what are you going to have to do? 4-letter word starting with F. FOIL, I agree. Here's my scratch word. X plus h squared. That's x plus h times x plus h. Let's FOIL that out. First, x times x, x squared, outer, x times h. I'm going to write it in alphabetical order. If I have two different letters appearing in the same term, x times h is the same thing as h times x. You'll see why in a moment. Enter. We have another hx. By writing it in alphabetical order, we're recognizing that we have like terms there that we can combine. Plus last, h squared, hx plus hx, that's 2hx. So we have x squared plus 2hx plus h squared. Any questions there? I think of myself as an optimist because I always think things could be worse. No matter how bad it is, things could be worse. Yeah, this could have been a cube. Suppose that had been a cube instead of a square. We'd still have to have another x plus h, distribute through another x, distribute through another h, combine like terms. So things could be worse. The squares aren't that bad. So I'm going to set this aside because I'm going to need that not only for this problem, but I'll need it for the next problem also. So I think we're almost through with part A. Remember I said part A is the longest part of these things. X plus h squared we figured out was x squared plus 2hx plus h squared. And I still have what stuck on there? The plus 9. Notice there are no like terms to combine. There's the answer for part A. Any questions there? The thing to remember is how you square x plus h. You can't just square x and square h. You have to write it twice and FOIL it out. Now part B. Part A is just that f of x plus h. Part B says take what you just found in part A and take away the original function. F of x plus h, that's part A, minus f of x. For part B, if you understand what they're asking for, you can get the answer without showing any work. That minus is working like the old-fashioned subtraction when you first started studying subtraction. That was, you had 5 apples, take away 2 apples. That's how that minus sign is working. It's working like take away. So f of x plus h, that's what we found in part A. So it says take part A, your answer in part A, and take away f of x is the original problem. So you take what we just found and take away the original terms. Which terms are about to drop off? Well, we'd have an x squared minus an x squared. So the x squared is gone. What else is going to be dropped off? No, because there's not an h squared in the original problem. the 9. 9 minus 9. The 9s are gone. You're taking the answer in part A and dropping the terms that are in the original function. And here's something you may want to remember. If you do this correctly, the only thing that's left must contain the letter h. We have left a 2hx plus an h squared. Any questions there? That's the answer for part B. You took what you found in part A and you take away the original function terms. Part C. It says to actually find the difference quotient f of x plus h minus f of x all over h. To do part C, you use the answer from part B. We know what that numerator is. That's what we just found, 2hx plus h squared. And they want us to divide it by h. The quickest way to divide a sum or difference by h is just to divide each term by h. So put each of those over h. You take what you have here in part B, you divide each term by h. Well, that h there cancels out. What are we going to be left with here in this second term? Can you cancel anything here? H squared divided by h? Yeah, we can cancel one h above and below. So we have left 2x plus, we have 1h remaining. Any questions there? Any questions? As I said, that first part is usually the longest part, or at least it's where students go wrong most frequently, because they just square the x and square the h without foiling. Let's type in these answers. So, x squared plus 2hx plus h squared, and then we have that plus 9. What was this answer? What am I going to type in here? 2hx plus h squared. I agree. Oh, and here we had to go through dividing each term by h. So what was our final answer for the difference quotient? 2x plus h. I agree. Any questions there? Well, there probably are, and you're just not sure how to word them. So let's just do another difference quotient. This is number 3. Number 3. Let me write the problem down. F of x equals a negative 8x squared plus 5x plus 8. Keep in mind, if you have to take a calculus class, you'll see why this difference quotient is important. If you don't have to take a calculus class, and this is just an exercise in abstract thought, there. I'm still going to break it into 3 parts. F of x plus h, then I'll take away the original function, then I'll divide through by h. So part A, f of x plus h. Well, there's more than one variable to replace here. This says go to your function f, and wherever you see a variable, there are two variables, there and there. Wherever you see a variable, replace it with x plus h. So I have a negative 8, replace the x with x plus h. I have a 5, replace the x with x plus h. And I have that plus 8 stuck on there. So, we see that we need x plus h squared. We already have x plus h squared right up here. It's already written out for us. We went through that earlier. Hey, but we have something in front of the x plus h. What is that? The x plus h squared. What have we got? A negative 8. So we're going to have to distribute through a negative 8. Any questions on my logic there? There's the expansion. We're going to distribute through a negative 8. So I'll get us started. Negative 8 times x squared, that's negative 8x squared. Okay, what's the next term going to be? A negative 8 times a positive 2hx. Negative 16hx. And here, okay, negative 8 times h squared is a negative 8h squared. Uh-oh, I better start writing. Should have moved everything over because we still have this plus 5 times x plus h. What are we going to have to do there? Okay, so we're going to distribute that 5 to give us a plus 5x plus a 5h. Do we have anything else stuck on there? The plus 8. Any questions on my logic there? We distributed the negative 8 over the x plus h squared. We had to distribute the positive 5 over the x plus 8h, and we still had that plus 8 stuck on. That's the longest part of the problem. If you understand what they're asking for, now we're ready for part B. They want us to find, I'll simplify f of x plus h minus f of x. Take what we just found and take away the original terms. Here's the original function, f of x. There's the original function. Okay, there's the original function. We're taking these terms away from the answer we just found. Which terms are going to drop off? You tell me. Okay, well, I'll start here. Is this term going to drop off, or is it going to stay in the answer? It's going to drop off. It's from the original function. It's gone. What about this term? Is it going to drop off, or is it going to stay? It's going to stay because it's not in the original function. So we have a negative 16hx. What about this thing? The minus 8h squared. It's going to stay also. It's not from the original. What about that plus 5x? It's going to drop off. 5x minus, take away 5x, it's gone. What about the 5h? It's going to stay. There's not a 5h in the original problem. And the 8, drop it off. 8 minus 8. Remember I said, if you do this second step correctly, every term must contain what letter? An H. Every term has to contain an H if you're doing it correctly. And finally, part C. We're supposed to divide through by h. Divide through by h. Remember I said divide each term by h. And the h cancels there, leaving me with what? I cancel. Okay, a negative 16x, I agree. What's going to cancel in this second term? Okay, so that square is gone, leaving you just a minus 8h. And here, the h cancels, leaving us just a plus 5. Negative 16x minus 8h plus 5. Any questions? No? Okay. Come over here. I'm going to type in. All they want is that f of x plus h minus f of x over h. All we type in is the final answer. I still broke it into 3 parts because it makes, breaking it into those 3 little parts makes it more, I think your brain can process it better. But all they want us to type in is the final answer, negative 16x minus h plus 5. Minus 8h and a plus 5. Is that what we had? Yes. Any questions there? We're looking at operations. We're looking at difference quotients. The next thing we're looking at is a new operation on functions called composition of functions. Okay, here goes composition. And these problems are going to get shorter. I keep saying, oh, this wasn't a long section, but composition of functions. Oh, I think this pen is going dry. Oh, shoot. Well, I'll throw it away. Here's one. This is an operation, but it's an operation that's unique to functions. There's no such thing as composition of real numbers. This is a function-only operation. We need a symbol to represent the operation. We use a little plus to represent addition. We use a dash to represent subtraction. If there's no symbol, you assume multiplication. So we can't just use no symbol for composition. But here's what they came up with. F composed with g of x. They use a little o. It looks like the word fog. F composed with g of x. That's defined to equal f of g of x. Composition is really just repeated function notation. It's saying go to f and plug in g of x. Notice that order. When it's written like this, f is on the outside, g is on the inside, but it could be reversed. G composed with f of x means g is the outer function and f of x is the inner function. Let's look at number 4. We're getting some shorter problems here, so if you're thinking, oh, these problems are taking so long, well, we're going to get some shorter ones now. F of x is equal to negative 2x minus 1, And g of x, no, oh, it's not a g, it's an h of x. Well, they can use any name they want to. I remember when we were discussing functions, when it was first introduced, I talked about my cost function and my profit function that I like to use in my business calculus class. I have c of x and p of x. So here they're using an h of x. That's fine. Let me write down what they want us to find. They want us to find h composed with f of 6. Let me move over to my paper now. I'll switch over to my paper. There. We already know how to use function notation. So let's just look right here. F of 6. Look at f of 6. Let's say an f of 6. We know how to find f of 6. That says go to f, and wherever you see a variable, you're going to replace it with f of 6. That says go to f. Wherever you see a variable, replace it with 6. Here's f. Let's replace that x with a 6. Here's my scratch work. We have a negative 2 times 6 minus 1. Negative 2 times 6 minus 1. That's hard to see, that minus 1, isn't it? I'll write it here. Negative 2 times 6 minus 1. Negative 12 minus 1. What is f of 6 equaling? What are we going to get there? Negative 12 minus 1. Maybe negative 13? So, f of 6 is negative 13. But we still have something over here. We have that h sitting in front of that negative 13. F of 6 is negative 13. Now we need to find h of negative 13. We plug the 6 into f. We take that result. We now plug it into the outer function h. So we go up here. We have a negative. Replace the x with the negative 13. What else do we still have here? The plus 1. So the opposite of negative 13, we know that's positive 13 plus 1 gives me a final answer of 14. That number is the number you plug into the inner function. We plug 6 into the function f, and then that result we plug into the function h. For a final answer of 14. Let me see. I think number 5 is one with a table. I'm not ready to do that one yet. I'm not sure that y'all saw that pattern. I'm going to make up one, okay? I'm going to make up a problem. Okay. Let's say we have f of x is equal to 3x minus 4. And let's say g of x is equal to 5x plus 2. And suppose they asked us to find f composed with a g at 0. They want us to find f composed with a g of 0. The inner function is where you start. G of 0. There's G of 0. That says go to G, and wherever you see a variable, replace it with 0. So you have 5. Here's G. 5 times 0 plus 2. What's that going to give us? 2, that's a 0 plus 2, so a 2. So we still have that f on the outside, but g of 0 is 2. So we plug the 0 into g, now we plug the 2 into f. Go into our function f, plug it in the 2, what are we going to get? Replace the x with 2. Oh, well, this is going to give us, what is that going to give us? 6 minus 4, looks like we got another 2. Let's go in the opposite direction now. Let's find g composed with f. We're still using these two functions that I made up, okay? G composed with f at 0. We start off by plugging 0 into which function? Okay, so we're plugging that 0 into f, 3x minus 4. So that's 3 times 0 minus 4. What's that going to give us? Negative 4. So we have a g on the outside and a negative 4 on the inside. We plug 0 into f. That gave us a negative 4. Now we plug negative 4 into g. So we go to g, 5, replace the x with negative 4. So we have a negative 20 plus 2. That's going to give me a negative 18. I agree. Any questions there? When we were looking at functions the first time, we looked at them as just ordered pairs, just sets of ordered pairs. I remember having problems where there was a little table or something, and I think that's what number 5 is going to be like. Let's look. Number 5. Okay, number 5, let me write it down. We have two functions and they're defined by tables. It's going to take me longer to write down these tables than it is to answer the question. So maybe you don't want to write down the tables. We'll recopy them. Okay, 12 is assigned to 10, 8 is assigned to 6, 3 is assigned to 4, and 20 is assigned to 21. Let me make sure I don't miscopy these tables. 4, 6, 12, 10. Oh, and they want us to find f composed with a g of 8. I better write that down. Otherwise, I'll be wondering, what do they want us to find there? Okay, switch over to my work. Right there. Here's number 5 down here. F composed with a g of 8. We work with the inside function, g of 8. G of 8. There's no equation to plug into. We're just going to have to go to the table, the g table function, and ask ourselves, what number is 8 assigned to? Go into table g. When x is 8, g is When x is 8, g assigns 8 to 6. So we have an f on the outside. We have an f on the outside. G of 8 is 6. Now, f of 6. We go to the f function. 6 is assigned to what number? 6 is assigned to 10. For my final answer, we start with the inner function g. 8 is assigned to 6. Then we go to the outer function f. 6 is assigned to 10. Any questions there? I said it'd take longer for me to write down those tables than to answer the question. Let's see, 10. I like this next one. They give us two tables. They want us to find, look at the composition they want. F composed with F at 8. What am I going to do with this G table? Am I going to do anything with it? That's just an unnecessary function. We don't need it. Let me write down number 6. All we need is the f of x table. 5 is assigned to 9. 8 is assigned to 5. And 11 is assigned to 7. And, oh, wait a minute. I better see what they wanted. It's f composed with f at 8. They're asking for f composed with f at 8. So, I start with my inner function, f being evaluated at 8. What's f of 8? Oh, I didn't switch, did I? I clicked on it, but it didn't. There it is. My inner function, f, is being evaluated at 8. What's f of 8? 5. So we still have that outside f. F of 8 is 5. Then what's f of 5? You go up here to 5. 5 is assigned to 9. It's just repeated function notation. Find f of 8. That gave you 5. Then find f of 5. That gave us 9. A composition of two functions at a number gives you a final answer that's a number. Suppose we have a composition of two functions at a variable. Notice a composition at a number gives you a final answer that's a number. But at number 7, we're finding a composition at a variable. That means you expect your final answer to be a function of that variable. Let me write down these two equations. This is number 7. F of x is equal to 6x minus 5. And g of x is equal to 7 minus 2x. They want us to find f composed with g of x and g composed with f of x. Notice we're going in, we're finding it in both directions. First, f composed with g. So we're trying to find f composed with g of x. that says take g of x and plug it into f. F is on the outside. G of x, that's a 7 minus 2x, is on the inside. So we go to f, replace any variable you see with 7 minus 2x. So we have a 6, replace the variable with 7 minus 2x. What have we got stuck on here? Minus 5, just checking to make sure y'all are still awake. And to simplify this, we can distribute the 6. That'll give me 42 minus there. I couldn't hear you. 12x, I agree. And we still have the minus 5. Well, we can combine the 42 minus 5. 42 minus 5, that's a 37 minus 12x for f composed with a g. They also want us to find g composed with f. In this case, my inside function is f of x. I'm going to have to take f of x and plug it into g. So g is still on the outside. F of x, we know that's 6x minus 5. So this says go to your function g, and wherever you see a variable, replace it with 6x minus 5. Here's my function g. Let me move that up. So here's my function g. I'm going to replace this variable here with 6x minus 5. So I have a 7 minus 2. Replace that x with 6x minus 5. Don't subtract the 7 minus 2. Remember your order of operations. You multiply before you subtract. So that 7 you just bring down. You distribute the negative 2 to give you here negative 12x, and here positive 10. Negative 2 times negative 5 gives us a positive 10. So we have a 17 minus 12x. For my final answer, any questions there? It is just repeated function notation. We typed in the answers. So f composed with g, that was the 37 minus 12x. And g composed with f, 17 minus 12x. Operations are classified as commutative or not commutative. For example, addition is commutative. A plus b always equals b plus a. What about subtraction? Is subtraction commutative? Does a minus b always equal b minus a? Rarely does that happen. So subtraction is not commutative. What about multiplication? What about multiplication? commutative and not commutative. Now set addition's commutative. A plus B is always equal to B plus A. And subtraction, I agree, I said that's not commutative. What about multiplication? A times B, it always equals B times A. So I'll just write out multiplication. That's commutative. What about division? No, A divided by B doesn't usually equal B divided by A. So here's my question. This new operation we have, composition, is it commutative? Does F composed with G always equal G composed with F? No, as a matter of fact, it usually doesn't. Sometimes it does, but most of the time it doesn't. Look at this previous example right here. 37 minus 12x and 17 minus 12x. So, composition, is not commutative. I put it in the wrong column, didn't I? So if they ask you to find F composed with G, and you mess up and find G composed with F, you're probably going to get the answer wrong on the test. Any questions there? The order in which those letters is written is important. Number 8. Let me write the problems down. F of x is equal to the linear function 9x plus 1, and g of x is equal to the square root of x. Let me switch. Same instructions as number 7. Find f composed with g of x and g composed with f of x. So here we go. F composed with g of x. What's my inside function? G of x. That second one there, that's the inside function. That says take g of x and plug it into f. We know that f is on the outside and that g of x is just the square root of x. So we have f of the square root of x. This notation now is saying go to f, and wherever you see a variable, replace it with. We've come to f. We're going to replace that variable with the square root of x. So we have 9. Replace the x with the square root of x. And we still have a plus 1. For f composed with the g. Now we have to go in the opposite direction. They want us to find g composed with f of x. What's my inside function? F of x is what's on the inside. F of x, we know that's 9x plus 1. G is still sitting there on the outside. And on the inside, we have f of x, 9x plus 1. So this says go to function g, and wherever you see a variable, what are we going to write here in place of this blue x? 9x plus 1. Realize in the first part, that plus 1 is not underneath the square root. But in the second one, is the plus 1 under it? Yes, it is. You go up there and you replace that all like that for a square root of 9x plus 1. Let's type in our answers. F composed with g of x, we have a 9 square root of 4. Is this what I want? Is that what I wanted to type? No, remember? The plus 1 is not under the square root, so tap a right arrow or click with your mouse, whatever you do to get out from underneath that radical on your device. You tell me how we're going to type this one in. What am I going to type first? The square root, and then everything else is underneath that square root. Any questions? Number 9, same instructions. Find f composed with g of x and g composed with f of x. But let me write down these these functions. F of x is the square root with 3x underneath it, and g of x is the reciprocal function 1 over x. Let me switch. There. So we have to find f composed with g and g composed with f. So first of all, f composed with g of x. What's the inside function? G of x, I agree. So f is underneath it, f is outside, and 1 over x is on the inside. So we have f of 1 over x. What is that saying to do? We go to our function f, and wherever we see a variable, we replace it with 1 over x. So we have a square root. That's 3. Instead of 3 times x, it's 3 times 1 over x. What's 3 times 1 over x? We can simplify this a little bit. Think of that 3 as 3 over 1, and remember how you multiply fractions. You multiply the numerator. 3 times 1 is 3, all over. Multiplying the denominators, what are we going to get? Well, 1 times x is x, so 3 over x. I remember in the first assignment talking about rationalizing. Oh my goodness, why didn't y'all tell me it's frozen? Well, shoot. Okay, well.